Hello friends, let us solve an example on in sands for estimating the bearing capacity of a pile. Right? Let us consider there is a pile and the water table the pile is inserted in a sand, and in the natural condition the water table is presented at a depth of 2 meter below the pile. And consider let us consider the dia of the pile, that is given as 30 centimeter, and the angular friction of the sand given it as a 35 degrees, and in natural or in saturated condition let us consider the gamma that will be equal to 21 kilonewton per meter cube, and let us assume that the adhesion factor that will be equal to k equal to 1, and let us imagine that nq value is given as 60 and also given tan delta value that is also given it as a 0.70, and let us assume the length of the pile is given as a 6 meter. If total length of the pile is given as 6 meter, if 2 meters is below above the water table, below the water table what is the length? 4 meter. And let us say that critical depth is given as a 3.6 meter, and they are asking us to estimate what is the safe load that we can apply on the pile by considering factor of safety is equal to 3, isn't it? Now, what we have to consider here, we have to, if you want to find out the safe, first we have to find out what is the vertical stress. Then only we will know the variation throughout the depth. So for that, we can also find out the average stress also. So as your critical depth is 3.6, that means what we can consider, you have to consider your variation in vertical stress up to the 3.6 meter depth only. After that, you can consider that it will be a constant, isn't it? Throughout the depth of the pile. So from here to here, what is the depth? 3.6 meter. If total is 6, 6 minus 2.6, how much will get? So constant will be 2.4 meters, right? So what will be the frictional resistance? Frictional resistance, how can I write it down? That will be equal to surface area into K into average vertical stress into tan delta, isn't it? If I expand this AS into K into average vertical stress, imagine if I take this term to the right side and AS into what is the constant term? Tan delta into, let me rewrite this. What are the constant terms? The constant terms are nothing but a K will be constant, and tan delta is also a constant parameter, and AS, how can I represent? Pi into D into L in general, we can write it down. Pi into D into L into, we can say it is a average stress. So if you just expand K into tan delta, diameter is also constant, pi into D into. Instead of finding the L average, see, I am taking in a separate value, average vertical stress. So instead of finding the average, we can find out up to 3.6 meter what is the stress, and after the remaining 2.5 meter what is the stress. Right? Let us express it here. So what about the vertical stress? Then let us draw the diagram again. Let us consider there is a pile. Imagine that it is vertical. And if I want to find out what is my variation of the vertical stress, so there will be a water table here. This water table is at a distance of 2 meter, and up to a 3.6 meter we are having the critical depth. So if your water table is here, then what will be the remaining depth? 3.6 minus 2. So from here to here, what is the remaining? 1.6 meter, right? So from here to here, it will be a constant variation. How much it will be? Total, if it is a 6 meter, 2 plus 1.6 meter, 3.6, 3.6 minus 6 or 6 minus 3.6. So how much it will be? 2.4 meters. So what will be the variation? If I represent the variation here, at the top, it will be is equal to 0. At the layer of 2 meter, what will be the vertical stress? What is the weight density we have to consider? We have to consider your weight density as 21. If it is 21, what is the value here? 2 into 21, how much it will be? 42 kilonewton per meter square. Now let us find what is the vertical stress at a depth of 3.6 meter. So my vertical stress at a depth of 3.6 meter, I can say up to 2 meter, as the soil is under natural condition, 2 into 21 plus remaining 1.6 meter, it is under submerged condition. So what is the submerged unit weight? The depth remaining 1.6 into total 21 minus gamma double, let us consider it as a 10. So how much will be? 42 plus 11 into 1.6. We are getting it as a 17.6. So if you are adding this, you are getting 59.6 kilonewton per meter square. So what will be the vertical stress at a depth of 3.6 meter? Then the value will be coming around it as a 59.6 kilonewton per meter square. So from here to here, it is under natural condition. From here to here, it is under submerged condition. So here, the slope will be different. Here also the slope will be different. So for the remaining depth, we will consider it as a constant. Why? Because up to critical depth only, we have to consider the variation. So 59.6 kilonewton per meter square. So what will be the vertical stress at the depth of the pile? At the depth of the pile, the vertical stress, we are considering it as a 59.6 kilonewton per meter square. So this is useful in finding the end bearing capacity. What will be the value for finding frictional resistance? We have to find out L into sigma average. That will be equal to divided into 3 parts and then find out the values up to 2 meters. What will be the average value? Then 2 into what is the average stress? We can write it down as a 42 plus 0 by 2 as it is varying linearly plus remaining 1.6 meter. What is the average value? The length is 1.6 into the average is nothing but a 59.6 plus 42 by 2, and the remaining term, how much it will be? 2.4 meter. So the remaining, it is nothing but a 2.4 into 59.6. 2.4 into 59.6. Then sum it up, how much you are getting? So this is what nothing but your L into average value. Now, what is your total ultimate load capacity of a pipe? That is nothing but a N bearing area. How can you write it down? Pi by 4 into what is the diameter square? 0.3 square into N bearing vertical stress is given as how much? 59.6 into whatever the length of the pile. Length of the pile, if I represent in centimeters, I can say it is a 60, isn't it? Now, if you go to the question, how much it is given? 30 centimeter. If you convert into meter, 0.3, right? So as I'm given 0.3, 59.6 into what about the 59.6 into area plus, sorry, into NQ will be there, right? What is the NQ value? NQ value is given as 60. What is the equation? How will find the ultimate bearing capacity? Ultimate capacity, that will nothing but a AB into QB plus AS into QS. AB is nothing but a pi by 4 into 0.3 square. What about the QB? QB is nothing but a vertical stress at the end into NQ. What is the vertical stress at the end of the pile? 59.6 into whatever the NQ value given, it is a 60. plus because of the surface area, how much it will be? 5 into 0.3 into what about the value? 1 into 0.7 into L average, L into average vertical stress. Now, we already find out what is the L into average value. Now, if you substitute it, then you will get it. Ultimate capacity of the file that we will get it as 507 kilonewton. But in the given question, we need the safe value. If you need the safe value, ultimate load by factor of safety, that will be given as 507 by factor of safety is given as 3. If you solve this, we'll get it is around 169.01 kilonewton. So what is the answer? The safe capacity of the pile, or what is the safe load you can apply on the pile, that is nothing but a 169 kilonewtons. So if it is a sand, you have to consider your vertical stress up to the critical depth. After that, you have to consider it as a constant. So don't be in a hurry to find out the average value. Always try to find out this value. So wherever there is a variation, until that you consider it the different part. That means if I see in this diagram, up to 2 meter, one type of variation, remaining 1.61 variation, remaining 2.4 another variation. So in the first 2 meter, what is the average value? Total length 2. What is the average? 42 plus 0 by 2. In the remaining 1.6, 1.6 into average 59.6 plus 42 by 2. Here, as it is a constant, what is the average value? 59.6. What is the remaining depth? 2.4. So like that, don't ever do find out complete average vertical stress for the total length of the pipe. And that will increase the length of the problem. So instead, so find out in a different parts. So we don't commit the mistake and the problem will be solved easily. Okay. Thank you.